Let's talk about orbits, the paths that anything in space will follow, from stars to pebbles. We'll start with the basics. The shape of an orbit is always an ellipse, a stretched out circle. The highest point in an orbit is called the apoapsis, and the lowest point is called the periapsis. If you add up both of these and divide by 2, you get the semi-major axis. Here's a mathematical visualization of that. Now that we know the basics, we can move on to our main topics: orbital velocity and Kepler's second law. We'll start with orbital velocity. Orbital velocity is simply the velocity of an object as it orbits. It can be represented mathematically as a function of height, like this. This looks complicated, but I'll explain it. A is the semi-major axis. mpg is the mass of the planet times Newton's gravitational constant, and it can also be known as mu. And h is the height above the center of the planet. It is the only variable in this equation. Note that orbital velocity is always tangent to the orbit. Also note that as h gets larger, v gets smaller. This will be important later. With orbital velocity out of the way, we can move on to Kepler's second law. Kepler's second law states that for any time period of length t, the area traced out by an orbiting object over t is equivalent. Let's look at an example. Here we have an elliptical orbit with an apoapsis of 25 million meters and periapsis of 7 million meters. This gives a semi-major axis of 16 million meters. We have a planetary mass equal to that of the Earth at 5.97 times 10 to the 24. Now we're going to zoom in far enough so that we can view the traced area as basically a triangle. We'll use a time interval of 0.1 seconds. We write out the equation, plug in our numbers for the apoapsis, and simplify. To get the distance traveled, we multiply by time, 0.1. To get our area triangle, we think of this distance as the base, the height as the height, and we can use the formula 1/2 base times height. This gives us this number as our area. I'll put it up top so you can remember it. Now we do the same for the periapsis. Take the equation, plug in our numbers, simplify, multiply by time, take h as our triangle height, and plug it into the triangle area formula to get our area. Believe it or not, it's the same as A1. Check it out for yourself on a calculator if you don't believe me. You may be asking why this is. Well, remember, a higher height means a lower velocity, which means less distance traveled. So when you multiply the distance by the height, they cancel out. Vice versa for lower altitudes. This concludes our discussion of orbits. I hope you enjoyed.